we don't have enough time to talk about today.
I'm not ready to talk about more details on that project just yet.
Major program at Tesla called Dojo.
A project we call Dojo.
A super powerful training computer.
A neural network training computer and a chip.
Hi, this is Warren Redlick. I want to do a bit of a talk today about full self-driving and Dojo. There was a presentation with Elon Musk and Andrej Karpathy, this big Autonomy Day presentation. Along with the Autonomy Day, there was another presentation, but the two of them gave some really interesting clues to what Dojo is and to what full self-driving is doing and what's coming with full self-driving version 4. So this video, I'm going to talk a deep dive into what is Dojo, what's coming with full self-driving 4, and what is it exactly that Tesla's software is doing to learn from driving. All right, are you ready? This is going to be fun. The first thing I think we need to talk about is how many miles Tesla is learning from. What you'll see with some of the discussion, whether it's Hyperchange or I've seen a couple of others talking about this, they'll talk about the number of miles that Tesla has driven with under autopilot, and that the system, the software, is learning from each mile driven under autopilot. I think that's wrong. Tesla is learning from every mile that is driven by every Tesla that has been built with full self-driving hardware in it, version 2 or version 3. If you bought a Tesla and you didn't pay for the full self-driving option, the hardware's in there anyway. Whenever you are driving, the software is watching how you drive. So I think the idea that people have is that the autopilot drives, and when you turn the steering wheel or hit the brake, that's a significant thing for the software to look at to say, okay, we need to learn from this.
The second you disengage autopilot for some reason because the software is not performing correctly, Tesla's going back, analyzing that footage.
You know, the disengage autopilot. And that's a really, Tesla uses this moment as well. That's a really important window into difficult cases.
And I think that underestimates the learning opportunities, and I think Tesla knows this. If you watch very carefully, they talk about this in a couple of the videos, whether it's Elon or Karpathy.
Essentially, like everyone's training the network all the time is what it amounts to. Whether autopilot is on or off, the network is being trained. Every mile that's driven for the car that's hardware 2 or above is training the network.
The software is running whether you have autopilot on or not. If you are driving your Tesla, the autopilot software is running and it is predicting a path. It is saying this is the path it would take if it were driving. And it compares that path to the path that you choose. And if it notices a significant difference, if you brake when it wouldn't have braked, if you steer significantly when it wouldn't have steered, that is another thing that it can learn from. It's not just learning from when you interfere with autopilot's operation, when you disengage. That's not the only thing it's looking at. And there's more. Keep in mind with hardware 3, there's 2 chips running. And each chip is capable of running the car on its own. So now imagine this, there's an update they're working on. Tesla downloads the updated version of the software, of the self-driving software to your computer. You're driving, it runs the current version of autopilot on one chip. It runs the updated version on another chip. And it is now able to compare, and you're driving, keep in mind you're driving, it is now able to compare how you drive to how the existing software drives to how the unreleased updated software drives. And it's able to look for variations, and then it's able to make comparisons.
They test the software in shadow mode, meaning they see how the new software compares to the current software by running it in parallel on the cars and seeing if there's disagreements.
So this is a tremendous difference in understanding how Tesla is using. This isn't a prediction, this isn't a guess. If you look at what Elon and Andrej Karpathy say, this is what they are doing. They are not just looking at autopilot engagements, they're looking at any opportunity to learn. And that feeds into Dojo. Everything that the full self-driving hardware sees is an opportunity for Dojo to learn. So that's the big thing that I think we need to understand. If you bought a Tesla Whether you paid for full self-driving or not, whether you paid for enhanced autopilot or not, whatever you paid for, if it was possible for them to put the full self-driving hardware in the car, it's in there, it's watching you drive. If you're running autopilot, then it's comparing whether it's looking for whether you disengage. But while it's running autopilot, the second chip is running a potential update. It may be running a potential update and comparing how the current software drives to how the potential update drives, and looking for whether you engage, whether you disengage the software. So many learning opportunities, and all of that is going to feed into how Tesla is going to use the hardware and software at the home office, at Fremont, where the autopilot team is working, where the software is working to learn from how you drive, how anybody who drives a Tesla drives. That all feeds into it. And that takes us into another issue. So if you look at Andrej Karpathy's talk at PyTorch and what he said at the Autonomy Day, the car is watching you drive, it's driving itself, and as it's driving, it's looking for things that are out of the ordinary. So in Autonomy Day, he talked at length about a bicycle on the back of a car. And originally the software saw a bicycle and saw a car and tracked them as two separate objects. And that wasn't the right way for the software to think about it, so they queried the fleet to look for similar images. And they used those images to train the software to recognize that when there's a bicycle that's on a car, that's attached to a car, that is just a car with a bicycle or just a car. It doesn't need to track two separate objects.
The neural network actually, when I joined, would actually create two detections. It would create a car detection and a bicycle detection. We take this image and we have a mechanism, a machine learning mechanism by which we can ask the fleet to source us examples that look like that. So as an example, these 6 images might come from the fleet. They all contain bikes on backs of cars.
Karpathy also talked about it's not just learning images. Karpathy's background is image recognition and using neural networks to enhance image recognition. But this isn't just about image recognition. This is about looking at situations that are presented to the car and making decisions, and not making decisions simply on a still image. Karpathy talked about one point about having a series of frames from 8 cameras, and it added up to 4,096 images.
Maybe we have 8 cameras, we unroll for 16 time steps, we use a batch size of, say, 32. Then we are going to be holding in memory 4,096 images and all of their activations in a single forward pass.
And how difficult it is to process all that, but that's what they're designing this hardware for. This hardware is designed to process full video from all 8 cameras, plus the radar, plus the sonar. It's using all of that information to make decisions, and rather than looking at a static moment in time, what do I see on all 8 cameras at this moment in time, it's looking at a series of frames together. Maybe it's 12 frames, maybe it's 3 seconds of frames. We don't actually know how much they're able to process. And then when there's a disengagement, when you're driving and you're driving, autopilot's just watching. When you're driving and autopilot notices a substantial difference between how you drive and how it's driving, it's able to query the fleet.
So you're driving down the highway, someone is on the left or on the right, and they cut in front of you into your lane. So here's a video showing the autopilot detecting that this car is intruding into our lane. We ask the fleet to please send us data whenever they see a car transition from a right lane to the center lane or from left to center. And then what we do is we rewind time backwards and we automatically can annotate that, hey, that car will in 1.3 seconds cut in front of you. And then we can use that for training the neural net.
It sends that your Tesla is going to upload data to the home office. They're going to get that data. They're going to say, okay, here's a moment where there was something that happened that we need to study. And they can query the fleet and they can send out to all the cars in the fleet, have you had something similar to this that we can look at? So they can compare multiple situations that are similar and see how the software handles it and how human drivers handle it. And one of the things, if you watch, there's a post on Reddit, or there are posts on Reddit where people talk about how many gigabytes their car is uploading. So when Tesla queries the fleet, it's looking for certain things, and if it finds something on your car is going to upload extra data to the fleet. If your car has a lot of disengagements, has a lot of unusual situations, your car is uploading that data to the home office. And the home office is then querying the fleet to look for similar situations to ones you encounter. So there's a lot of data. There's downloading, right? There's over-the-air updates, and your Tesla is getting new software from Tesla. Sure, from the home office. But at the same time, the home office is learning from you. It's learning from every car out there.
You might not want to annotate all the drivers. You might want to just imitate the better drivers. And there's many technical ways that we actually slice and dice that data.
And all that data is being uploaded. Not all the data, by the way. Your car is generating a huge amount of data. But as they've talked about, they don't need to upload the data of you following, driving down the middle of the lane on a highway. They've already got that. They're only uploading the data from incidents where the human driver diverges significantly from the software, or when the existing software diverges significantly from the other software that they're testing on the second chip.
I mean, the crazy thing is, the network is predicting paths it can't even see with incredibly high accuracy.
The big question I wanted to talk about when I started thinking about making this video is, what is Dojo? We've heard Elon talk about Dojo. We've heard Andrej Karpathy talk about Dojo. There's this whole mystery about what it is.
Major program at Tesla, which we don't have enough time to talk about today, called Dojo. That's a super powerful training computer.
The hardware team is also working on a project we call Dojo. And Dojo is a neural network training computer and a chip. And so we hope to do the exact same thing for training as we did for inference, improve basically the efficiency by roughly an order of magnitude at a lower cost. But I'm not ready to talk about more details on that project just yet.
So I have a few theories about what Dojo might be. My wild theory that I'm pretty sure is wrong, okay? I got some more rational theories coming, but my wild theory I'm pretty sure that I'm wrong about is that they've developed a quantum computer to do neural network processing, because the idea of quantum computing is you can test multiple ideas, multiple possibilities at once. So the idea of being able to test multiple paths that the software might take and then compare that to how the human driver does would be very interesting. Now, I don't think they're using quantum computing. It's a wild theory. Maybe it's something they'll do down the road. One of the things I looked at was I looked at Tesla hiring. I looked to see what they hire for. I looked on LinkedIn to see people who work for Tesla. I was not able to find any examples of anyone working for Tesla or any jobs Tesla's hiring for that involve quantum computing. So although I think it would be a really cool idea, and down the road somebody's going to come up with some kind of neural network that uses quantum computing and there'll be some brilliant breakthrough and that'll make a huge difference in everything, I don't think we're there yet, and I don't think that's what Tesla is doing. Now, another idea that I think Tesla might be doing is, I think they might be taking the existing hardware 3 chips, okay? And just like there's a GPU cluster, there's a cluster of graphical processing units that they're using, they have been using this and they are using this to learn from how we drive, how the car drives, how other drivers drive. There's also a reference to Dojo. I don't think Dojo is just one chip. Elon has said, maybe it was Andrej Karpathy, one of them said that Dojo is a neural network on a chip.
A Dojo is a neural network training computer and a chip.
But it's not just one chip. I think what's going on is there is a cluster of neural network chips that forms a larger neural network that is learning. So the simplest theory would be that they're taking the existing hardware 3 chips that are being used in the Tesla Model 3 and the current Tesla Model S and X and the future Model Y. They're using that existing hardware 3 chip.
And if we used all 12 CPUs to process that network, we could do 1.5 frames per second. If we use the 600 gigaflop GPU, the same network, we'd get 17 frames per second. The neural network accelerators on the chip can deliver 2100 frames per second. We ran it on the old hardware in a loop as quick as possible, and we delivered 110 frames per second. For the new FSD computer, we can get 2300 frames per second processed. So a factor of 21.
I think this is perhaps the most significant slide. It's night and day.
And they've built some kind of cluster that uses the neural networks on each chip, forms a larger neural network, and is able to process at a much higher level. So I think that's a pretty reasonable theory about where Tesla might be going with this. And it fits. That's something that's it's not straightforward in terms of the software programming, but in terms of the hardware end of it, we're already making all these chips. We'll just make 1,000 more. They're making hundreds of thousands of these chips, and you just make 1,000 for the cluster. And that's another interesting question that's a tough one. How many chips do they have in the cluster? Because this is supposed to be this super powerful computer. Maybe they found out a way to do it with 1,024 chips. Maybe they're doing it with 100,000 chips. Who knows? They can make as many as they want. It would be a very high power consumption, but that for the purpose they're trying to achieve, it might make sense for them to do a lot of it. So I don't think we're talking about a 1,000,000 chip cluster, but there's a very good chance the cluster has 1,000 chips or 10,000 chips. So that's one theory. And I think that may be the most sensible theory. We've gone from the crazy theory about quantum computing to the sensible theory that they just took a bunch of hardware 3 chips. Now, we know in the videos, we know that Tesla has been developing hardware 4.
We finished this design like maybe 1.5, 2 years ago and began design of the next generation. We're not talking about the next generation today, but we're about halfway through it. It'll be at least, let's say, 3 times better than the current system.
So another theory is that they already have prototypes of Tesla full self-driving version 4. And they're using the early chips from version 4, from FSD4. They're using those early chips to create a Dojo cluster. And they're using those early chips, and that's able to process. Keep in mind that Elon has said that hardware version 4 will be able to process at roughly 3 times. It will be 3 times as good as hardware version 3 in all the important ways. I don't think power consumption was one that he thought was that important to improve by 3-fold, but processing speed, the ability to process large-scale video, it makes sense to me. I'm not saying it's more sensible than the hardware 3 version, because there's this question, is hardware version 4 done? But if they're developing Dojo, and Dojo is still this, as Elon calls it, a major program, if they're developing Dojo for this purpose, it could be that they're using Dojo on the one hand to process more information rapidly, and on the other hand, to test out FSD version 4. So those are 2, I think, somewhat reasonable theories. I think it's optimistic to say that version 4 is that ready that they could do it, but at the same time, they've been working on it for close to 3 years now, and in chip development world time, that's a long time. It may be ready. So that's another theory. Regardless, the idea is that whatever Dojo is, it's taking in information at a video level. Now, this is something that I wanted to talk about as well. If you watch Karpathy talk, there are times when and Elon has mentioned this too, there's these references to vector space, and Karpathy uses some video where you're looking at a top-down image that the car is driving through. There's one he did with Smart Summit, and it's driving through a parking lot.
Here we are plugging in 3 cameras simultaneously into a neural network, and the network's predictions are not anymore in the image space, they are in the top-down space. Now, here we are making predictions in the image, and then we are, of course, casting them out and stitching them up across space and time to understand sort of the layout of the scene around us. So here's an example of this occupancy grid. We're showing just the road edges and how they get projected.
So there's the high level that we operate on, at least we think we operate on, where we operate on what we see, and we process that directly into action. There's a view that Tesla takes the visual information that it gets from the cameras, and it reduces that to a 2 or 3D space, and that each object in the space becomes a vector with properties. So there's the Tesla itself and its size and what direction it's going and how fast it's going. There's this object over here, it's a stop sign, it's not moving, it's red. There's a traffic light, there's a car that's moving, and This is the rough size of that car, and this is the direction it's moving, and this is how fast it's moving. These are all properties of objects that the Tesla is seeing, and those can be reduced to some kind of vector space, and the information can be processed on the vector level, which makes sense to me from an efficiency standpoint, that it would be easier to do the processing and decision making at that lower level. But the idea of Dojo, if you take Elon at what he said,
Goal of Dojo will be to be able to take in vast amounts of data and train at a video level and do unsupervised massive training of vast amounts of video with the Dojo program, Dojo computer.
that it's processing all of this information at a video level. The idea is that the software is now making decisions based on what it sees without taking the intermediate step of putting everything in vector space and operating on vector space. I relate to this personally. I speak multiple languages. I speak Spanish, in particular Spanish and Japanese. A little bit of French, but I'm not that good at French. But Spanish and Japanese I speak fairly well. And I lived in Japan and I traveled in Europe. And I live in Florida and I've lived in Texas and California, so I've had a lot of opportunities to deal with Spanish. When you are in a country that speaks another language than yours, and you know that language, when you're first doing it, you hear something in that language. Let's say I hear something in Japanese. You translate it in your head to English, and then you act, or you then say something back and you think, how would I answer that in English? And then you translate it back into Japanese. But at a certain point, you reach a level where you're able to think in the other language. And it becomes much easier. And I think that's really what fluency is in a language, is when you're able to think and operate in that language without having to translate back to your native language. And that's an analogy that I think makes sense for what Elon said about Dojo, is that instead of the computer processing the information that it takes visually, reducing it to vector space, making decisions in vector space and sending commands to the car, turn left, accelerate, brake, whatever. If the computer is able to process at video level and skip the vector space step and translate that directly to action, that could make the car more responsive. It could reduce reaction time. It could mean it makes better decisions, just like I think when I'm acting in Japan and I'm actually thinking in Japanese rather than translating. I think it just leads to better decision making as well. So again, that's a theory. I don't know how else you would interpret what Elon said about processing information at a video level. I think that's the only way that makes sense. So I hope that's helpful. Well, thank you for watching. I hope you liked this video, and I hope this was informative and gave you something to think about. If you have your own ideas about how Tesla is learning, how Tesla's software is learning from self-driving, from people driving, from the computers watching people driving, and in particular, if you have your own thoughts about what you think Dojo is, what is the plan with Dojo? I'd love to see what your comments are. I'd love to hear some other ideas about what Dojo might be. So in the comments below the video, please make sure you let me know. Tell the world what you think Dojo is, and what do you think Hardware 4 might be? Any other ideas? How are they learning? How are they deciding who the best drivers are that they should watch? That was a really interesting clip earlier in the video, where Karpathy said they're not just annotating all drivers, they're looking for the best drivers, and they have ways of measuring that. So how are they doing that? Just let me know what you think. There's a lot in this video, and I'd love to hear your thoughts. And of course, if you're not already a subscriber, please subscribe, check out some of my other videos, and let me know what you think of those videos too. Thanks again for watching.